sheet, single sheet they will take, and they will do some processes like cutting, punching, piercing, bending, some operations they will perform to create a component. In bending, what they will do, they will place one die at this location. They will place one die here, like that, and they will apply force here, direction. So what happened here? This portion will get lifted. Okay, this portion will get lifted from here, and it will make component something in L kind of. The component. Okay, and here you will not get any, see, whenever you perform the bending operation, you will not get any sharp edges. Here you will get some curvature kind of thing. Okay, here you will get some curvature kind of thing. This curvature we can say as a bend radius or bend radius. The radius, if you measure the radius here, this one we can say as a bend radius. See, always whenever you are creating the shipment component, so whenever you come across a term like bend radius, it is the inner one. Okay, it is the inner one, not the outer one. So here bend radius. So in sheet metal parameter also you can find the option sheet thickness and sheet radius. Like bend radius will ask you there. So bend radius is this. So whenever you are performing the bending operation, so when the plate or when the sheet is going to bend, what happened? It will make some curvature shape. Don't make sharp edges. If you make a sharp edges, it will crack at this location. If you make a sharp edge here, it will crack your object in this location. So the object is going to damage. So for that reason, the radius should be there. And remember one thing: every sheet thickness, we have some standard thicknesses are there in sheet. For different material, different standard thicknesses are there. So based on the thickness only, bend radius also standard only. Okay, based on thickness, the radius also will become standard. Okay, suppose for example, if you take the sheet thickness as 0.12 inch, for example. Okay, 0.12 inch if you take the sheet thickness, so bend radius will become here almost something like similar 0.1 inches. Okay, suppose for example, if you have sheet thickness as 0.25, for example, so your bend radius will become approximately like that. Based on the material and based on the thickness of the sheet, the radius will get automatically calculated like standard values are. Okay, so like that it happens in the production. The same thing happened in the design also. So whenever see, these things you can able to create in the part design also, but the difference you can find here is, see here what we will do in sheet metal. We will take one sheet. For example, this is my sheet. Okay, this is the front view of the sheet, and if I take the top view here, it will look something like this. For example, here I have the bend line. Okay, here I have bend line. Means here from here I am bending my object. This is my bend line. See here, guys. So many times I think you will find you here, because currently I am working on sheet metal designs only. So I am taking technologies here so that you can understand, and when you go to the company, you can able to understand the technologies. Okay, one by one we will tell them technologies here. The first thing, see here, sheet metal. I am explaining what is sheet metal. Okay, uniform thickness, and which uniform thickness the first thing, and by using some standard or separate production process, we are creating some components like bending processes. So those components you can say as a sheet metal components. Okay, the next in sheet metal, the first thing we can find here is bends. What is bend here? Bend you already know. Bending means folding the thing. That's what we can say as a bend. So here, here also the bends are same similar like the round. Okay, so when you are folding this object from this point, that thing we can say as a bend, and the line from where you are bending your object, that line we can say as a bend. So here the line which you are seeing here, now this line we can say as a bend line. Means from that line I am bending my object. Okay, this is my bend line option. So here, for example, this is my object. Example, this is my object, and here I have one line. One bend line here. So the object is bending from here, like that. This is my bend line. So from this bend line, the is bending and it's moving upward direction like that. So it is becoming like this. For example, I have a one cutout here. Cutout in the sense hole we can say. Usually in sheet metal we cannot say holes. For circular thing only we can say hole. For remaining all we can say as a cutout. Okay. Here I have one cutout, or we can say rectangular pocket or hole we can say. Okay. So what we will do is, in real time production process, after bending we will not make hole like this. Before bending only we will take this sheet, we will make this cutout first by using punching process. By using punching, we will make one, place one die here and we will press, and it will make a hole here, like this rectangular pocket we will make here. Then after that one we will make a bending operation. Okay, that is the process we are following here in the. So after bending we cannot able to make this hole perfect. So that is the reason what we will do. We will first cut out, make the cutout, then we will go for the bending process. Okay, so this is the bend line. The next thing is here. See, here we are bending here. Now the process we can say as a bending, and after creating this thing we can say as a flange. After using the bending process, if the final output we can say as a flanging or flange. Okay, these things we can say as a flanges. The next thing is here. After what the next terminology here, you can find some more terminologies here. Line, bend, allowance. After you can find bend allowance. See, these all are standard values. We don't want to bother about these values, right? Because what happened means, if you go to the company, for every material they will calculate and they will base these values in the software only. The software will automatically calculate these things and it will directly create by taking those values. What is K factor? Nothing is there. Here you have the bend line now. So that bend line divided by total thickness. Some formula is. So based on that formula only we will calculate K factor, and based on this K factor also bend allowance. Okay. Yeah, one more thing will come here that is very important. That is, whenever you are creating the sheet metal component, one term will come here, that is flat pattern. Okay, this terminology is very important when you are performing the sheet metal designs. Okay, what is flat pattern? Okay, see here. This one we can say as a flat, means after performing operation, before performing the bending operation, how the sheet is there, that sheet say as a flat. Suppose for example, you made this model. Okay, one base is there, one flange is there, and cutout is there. So this is my object. So what we will do in real time, production processes, we are using CNC machines. Okay, so CNC machines here, our sheet is not exactly this much size. My sheet is somewhat bigger, somewhat smaller. So many kinds of sheets are there. Mostly bigger sheets will be preferred, and from that one will how much sheet is required will. So I have this sheet from, for example, I have this big sheet. From this big sheet, I want only a small portion. For example, I want only this sheet. So what we will do, we will cut this sheet from this big sheet by using CNC machines. Initially, we will use some lathe machines or some different kind of machines are there for cutting processes. By using those machines, we will cut. But right now, we are going to the advanced era. So in that one, what we will do, we will use CNC machines. So CNC machines will work on programming computer. Okay, it will only work on programming. So we have to directly go give the codes to that machine. It will generate or it will create that model line according to our requirement. So, so when we have to cut this one, so what we have to do, we have to create the, after creating this model in the software, we have to again create that model into the flat pattern. Means how much length of the sheet you require. Okay, how much length? I have this much big sheet. From that sheet, how much you require, that one you have to specify in the code. So for that reason, what we will do, we will create the flat pattern by measuring this length and measuring these two lengths. We measure and we will cut this length and width from this big sheet. Then we will go for the further procedures. Okay, I will tell you how to create the flat patterns later, but mostly in drafting. Okay, in drafting it will come. Usually we have to create under sheet metal design only, but you cannot able to see under sheet metal. You have to see this thing under drafting. So at that time again I will explain this. So this is flat pattern is also very easy. Flat pattern is very important here. And remember one thing, whenever you are giving the flat pattern, always give dimension in an ordinate dimension. See here we have two types of dimensions are there. One is general dimension, or we can say form dimension. One is form dimension, the other one is ordinate dimension. I think you people know AutoCAD software very well. AutoCAD you have learned coordinate systems, absolute coordinate system, relative rectangular coordinate system, and polar coordinate system. So coordinate means the x and y values. So here also the same thing. Ordinate means x and y values. Suppose for example I created this flat pattern I created, then what we have to do, we have to specify the dimension for this. So what we will do, this one I will take as x is equals to 0, and this one we have to take as y equals to 0. These two things we will take. Then what we will do, what is the length of this line is there. So here we will take x value as, for example, 100 mm is the length of the, and y value already we specified 0. So these coordinate values we have to specify. This one I am giving like 10, and this one I am taking like 0. So like that we have to specify the values in ordinate dimensions. I will show you how to give the ordinate dimensions also. So like that we have to create the flat patterns. Why? Because after creating this flat pattern, after giving the ordinate dimension, directly we will save this one to DXF file. So why we are using DXF file? To generate the codes for CNC. For generating the codes for CNC, we are creating DXF file. If you import DXF file in CNC software, it will automatically generate the codes. Okay, that is the reason we are giving the ordinate dimension and we are creating the DXF. So flat pattern is very important. Then form dimension, ordinate dimension. Ordinate dimension we are giving on flat patterns, and form dimensions we are giving on the, this one we can say as a formed views. This one we can say as a flat pattern. In flat pattern we will get ordinate dimension, and in formed views we will get the formed dimension like length, width, like this base length will give, and this flange length. Okay, so like that we will give dimensions. Understand this one? So after that one, what is the next thing? Form dimension, ordinate dimension, flat patterns. like when you go to the software, if any new technologies come, again I will tell you. Now, like that we can able to make the pockets. Now I am going to the software here. I already said that whenever you enter into the sheet metal parameters, sheet metal design in Catia software, the first thing you have to do is you have to keep the sheet metal parameters. So go for sheet metal parameters. Click on that one. Sheet standard files. If you standard file, you can take from there. You will search for that if any sheet standard files are. Because I am using the crack version software, if I get on something I cannot able to place there. It is administration customization standard. We cannot able to keep that one. So what I will do, I will keep manually. 0.079. Okay, it's here for example 0.12 inches is my thickness and 0.12 is my bend radius. Okay, then bend extremities, some I will tell you later. Bend allowance, I already said that bend allowance and K factor. I already tell you about this. Okay, this one it will automatically calculate by using the formula. Here we have one formula. Automatically by using this formula, it will calculate the bend allowance. Now it mentioned here logarithm. Hello guys, are you getting my voice?
Yes, sir.
Hello.
Yes, sir.
Yes, sir. Hello. Yeah, actually the power's gone just now, so I connected the mobile now. Okay, now see here guys, I already tell you about this bend allowance formula. Here we have like logarithm minimum 100, maximum 20, sheet metal parameter bend radius. Sheet metal parameter by thickness, like that one formula is there. So based on that formula, it will automatically calculate your bend K factor or bend allowance K factor, you can say. Okay, this one automatically it will calculate based on your sheet thickness and your bend radius. Bend extremities I will tell you later. Here we have some options like minimum with no relief, square relief, round relief, linear, tangent, maximum close, flat joint, like that we have some options. I will tell you that one later. Then we have parameters. In parameters I am giving thickness and bend radius. If you go to the company, they will not give any manual values. Directly they will go for sheet standard files. What material required, they will select that material. Automatically it will take your thickness, bend radius, bend allowance formula value, and what we can say, somewhat more is there, like reliefs, round reliefs, square relief. Just now we see in the pen extremities, those reliefs are there. Those reliefs also will automatically calculate and it will automatically apply when you go to the option. Now see here I have given the thickness and bend radius. Click OK. Now what I am doing here, now what we have to do, first of all, see here we have to create one sketch. See here mostly like surfacing, I said already that in surfacing everything we have to do under 3D only. Because here also you can find the same thing, everything you can find here. Suppose for example I am creating one component, like first of all we require the first sketch. First of all in in sheet metal, first sketch you have to get, anyhow you have to get the sketch. Okay, so I am taking this plane for creating the sketch, and I am creating one rectangle, center rectangle. Let's give some dimensions here. I've given 0.12. maybe like 12 inch. This one I am giving like, mostly if you go to US based companies you can find feet and inches only. So here I am giving some is a this will take I will give 45. I is the width of the sheet. Exactly. Now see here, this is my scale. Here I have the first command, that is recon size. Recognize. Recognize is a command is used to convert your 3D model to sheet. Like if you create any model in part design, that model if I want to convert it to sheet metal, we have to use this option. Why we require to convert that to part design component to sheet metal means, see here if you create any component in part and you cannot able to convert it into flat part. Every sheet metal component you need to create a flat part. Compulsory. If you are creating any sheet metal component, compulsory you have to create a flat part. Then the component will not be exists. Okay, so it's must. So that is the reason if you are doing the production of sheet metal, flat part is must. So right now I don't have any part. Like I didn't build any part, so I am not using that option. Later we'll check the option. Now what I will do, I will go for the next option, that is the first command which is used to create the sheet, like first feature. In different software, different names are there for this. If you go for example, if you go for NX, you can find the option tab. Okay, tab, TAB tab. Here also you can find something like tab. In different software, different names are there. Here in Catia, we say this one as a wall. Primary wall we can say, primary tab we can say, primary wall or only wall also we can say. So I am going for the wall option. It will open this wall definition. So in wall definition, first of all, it is asking you to select the profile, means which profile you want to make as a wall. So it should be closed only. Remember that. It should be closed only. It should not be open. So that is the reason what I will do. I am selecting this profile. Okay. My sketch has been selected here. Initially, what happened when I taken this command? It is OK and preview is disabled. Why? Because I didn't select anything. Like profile, it didn't select anything. So first of all, you have to select the profile. Suppose for example, if you didn't create any sketch, at that time also, and you have taken the command, at that time also nothing to worry. You can able to create your sketch from here also. How? Beside that selection option, you have an option that is sketch. If you click on that one, it will ask you to select the plane on which plane you want to create the sketch. I want to create sketch on this one, for example. Now again it will return to the sketch environment. Whatever sketch you want you can create. Then click on exit home page. Then automatically your profile has been created. But right now I already created my profile. So what I am doing, I am selecting the profile. Now see here, it is creating the wall. When you carefully see here, this wall has been created above the sketch. Okay, the wall has been created above the sketch. So this is my sketch at the bottom side, and above the sketch it has been created. Suppose for example, I don't want upside, I want downside of my sketch. So what you have to do, you have to just click on invert materials. So what happened here, it will move to the bottom side. Bottom side, upside. Like that we can able to do it. Like this. Okay, upside, bottom side. Suppose for example, if I want to make my sketch in the middle of the object, so in that case what we have to do, just have to enable this option. Now see here, your sketch is coming in the middle of the object. Initially it is coming either downside or top side. But right now it's coming in the middle. Why? Because I have choose the option here, sketch at middle position. So whatever option you want you can choose. Mostly we will use this one, sketch at extreme position. Okay, mostly we will use sketch in extreme position option, and then click OK. Now see here, my first profile or my first wall has been created. Now we can say primary wall or we can say primary tab. Okay, here the first wall has been created. The next thing is secondary wall. In Alex, we can say as a secondary tab. Here we can say as a wall on edge. Okay. In Catia, we can say this one as a wall on edge. That is the second option. Okay. Wall on edge. So when you go for the option wall on edge, means it will create the flange. Just now I said in the like here, these kind of walls we can create. Right now, from here onward, see, after creating your first sketch, only for after that we don't require any sketch further. Further, you don't require any sketch for adding material. Just if you have used that option, it will automatically generate your profile. But the thing is, if I want to remove the material, in that case again we require the sketch. Okay, again we require the sketch. So for that one, what I am doing here, wall on edge. See here, I said here. So for example, this is my flange also we can say, or wall also we can say. So I want to create this wall from this edge. Okay, from this edge I want to create the wall. So what you have to do, first of all, it's asking me to select the profile. Okay, it's not showing any here, but it is asking to select the profile. For example, I am selecting this is my profile. Now see here, automatically your wall has been created. Just what you have to do, you have to specify the parameters. Okay, just you required here the parameters. You have to specify the parameters like length, width. That's it. It will automatically generate your flange wall on edge. Okay. Now see here height. How much height you require? Right. See here we have so many options are there to specify the heights. One by one we'll check what are the options and how it will look like here. I'm going to the right side view here. Now see here I want 5 inches height. So the value whatever you are entering here, so from where it should measure, right? Because we have so many options to measure. Initially it will measure from the bottom edge. From this edge it will measure. Now see it is selecting multiple edges here. I don't want multiple. Go for wall on edge. Selecting this edge. Now see here, initially it is measuring your length from whatever value you are entering here. Now it will measure from the bottom edge of the flange or wall. Okay, so the height is looking like that. For example, I don't want to measure from here, I want to measure from other positions. So I am giving this position. So what it will do? See here the height somewhat increase here. Why? Because right now it's measuring from the center of this bend radius. Okay? Center of this bend radius. If you choose this option. If I am choosing the option from here means the end point of this bend radius. Okay, the end point of this bend from here is measuring. So here also it increases the height somewhat here. Now I am going for the next option, that is my the next height option I am giving here. If you choose this option, what it will do, it will again measure from the intersection point of those two edges. From that point, it will measure your wall height. Okay, like that. Here we have two options are there. Height. If you want to specify height, you can specify. For example, if you don't want to specify or you want to give the up to next option. Like for example, I want to give the height by selecting the reference object, means you have to go for the option. Okay, so for that one you have to go for the option up to plane or you have any plane or surface or outside height here. So you can select the so this that height to create what flanges or wall on. So this is my option. So right now I don't have any planes or surface here outside. So that's the reason I have option. The next option we can find here is angle. Okay. The next option we can find here is angle. How much angle you want to keep? See here right now it's taking as 90 degrees. Means the angle between this face to this face how much you require. Right now showing as 90 degrees. Okay, right now showing as 90 degrees. If you want increase or decrease the angle of the flange, you can able to do here by choosing the option. How much angle you require? For example, I want here 120 degrees. Okay, just specify the value like 120 degrees. Now see here, the flange has been created with a 120 degrees angle. Okay, 120 degrees angle has been taken here, and for that angle it is created here on edge or flange. See here guys, don't get confused here what is flange and what is edge. Both are similar. Okay, both are similar. You cannot find that much difference. That is the not problem. That is the thing. Why? Because again, in later you can find the later you can find some more command which name is flange. See here, here you can find flange. Both are similar only. One on edge has different process to create. Flange has different process to create. That is the only difference. But both the things are similar. I will show you what is the difference there later. Now again double click on this flange. Now I said about the angle. Angle also you can able to specify the reference. Like you can able to give ordinate orientation plane and you can able to specify the angle how much you require. So both the options you can use to create the ball on edge or flange. Okay. The next option you can find here is that is a very big problem which we are facing. That is your deviation. Like for example, if you go for the option here, like orientation angle, we have selected the orientation plane to create the flange. For example, if you have any orientation plane, then for example, right now I don't have any orientation plane. If I choose also, for example, I am giving orientation plane as for example this one, it will show you some error like that. Why? Because we require some angular dimension. We require angular component. That is the reason it is not allowed. Okay, understand this one.
Yes, sir.
Now, the next option you can find here is I don't want this one. I go for angle only. Angle I have specified there. This clearance, everything I will tell you later. Now I will show you the. See, right now it's coming in the upward direction of that. It's coming in a upward direction. If you want in a downward direction, just go for reverse position. Like that. You can change the direction of the flange here. The next option you can find here is inward material side. When you carefully see here, I am giving the angle as 90 degrees. I'll just make zoom in here. What is the difference you can find when you go for the inward material side? If you go for inward material side, see, initially your flange is somewhere here, but right now it's showing somewhere here. Why? Because it is going somewhat inside when you choose the option inward material side. Okay, inward material side. So like that we can create. If you go for preview, it is coming inside. Why it is like that? See here, initially what happened, you have selected this edge for flange. Okay, you have selected this edge for flange. But right now see here, this edge, whatever you selected now for creating the flange, it is matching with the outer face of the flange. If you want to make this one to match the inner face of the flange, which you can go for the inward material side. Now see here, it is matching with the inner one. Okay, it is matching with the inner one. So like that you can able to change it. Suppose for example, if you don't want the bend here, see here you can find the bend radius or bend here. If you don't want that bend, just disable this bend radius. If you disable this, what happen? Here the bend radius has been removed from the option. Okay, the bend radius has been removed from the option. Okay, the next option you can find here is no clearance. See here, when you carefully see, there is no gap between those two edges, flange edge and this primary tab edge. You cannot find any gap. If you want to give it, that's the reason it is showing like no clearance. If you want to give any clearance here, so you have to go here some, for example, 0.5 inches. So what happened here? It is giving some gap between those two surfaces. Okay, it is creating the gap between these two surfaces. That is my next option. Okay, like that you can able to. And the next thing is, this is your monodirectional, means in both the direction it is moving it. But when you go for the unidirectional option, you can go for sorry, this is your mono means single only. If you go for bidirectional, what happened here? Yeah, both the edges got lifted. Bidirectionally, clearance code is not working here. Why? Because the created formula links the wall position with shape. Parameters bend values. If you change the distributor parameter bend value, the order split position actually do you want to create this formula. So you have to create one formula for this one. So based on that formula, it will create your bidirectional. I don't want the bidirectional, I want only unidirectional. The next option you can find here is with bend radius without bend radius. This one I said that if you don't want to create the flange or wall on edge without bend or without bend radius, you can do that one. Or if you want that one, you just go for the bend radius formula. Okay, so this is my bond on edge option. So if you want the with bend, without bend, you can able to create it. Okay, the next thing is extremities. See here right now it's created for the complete edge. Okay, the flange or wall on edge is creating for the complete edge. If you don't want to create for the complete edge, you can able to limit the. For example, I want to limit in this direction. For example, just select the face of our plane here. From that plane, how much distance you want to be able to specify. For example, I am giving some 1 inch. It's increasing the edge. Now see, it is making it the right direction, means it's increasing the flange length value. I don't want to increase, I want to decrease. So for that reason, what I will do, I will give -1. So what it will do, it will remove that. Face wall edge with bend feature invert in and updates. Okay, it requires an update here. So let me go the things. Suppose for example, if I want to make it the second direction, you can go for second direction. Select this option and select these steps. Here also it's not taking the value. How much gap you require to specify here, then it automatically creates the gaps. Okay, this is your this option. The next option you can find here is sketch. Sketch base. Initially, what I have done, I have created one flange here. So that flange is automatically created, like it's a rectangular shape and it's automatically created. I don't want this rectangular kind of flange. I want some other shape. So for that reason, you have to create it. So in that case, what you have to do, you have to go for the option here, color edge. Take the option sketch base. It is asking you to select the edge first. Yes, I want to go for the profile and create the sketch. You have to create the sketch here. See what edge you are selecting, that can only you have to select. So I selected this edge, so I am selecting this plane for the sketch. Go for this option. Select this plane. It's not taken. Okay. Click on this option, then select this plane face. It will enter here. So we have selected the bottom edge, so the sketch should be closed and the bottom edge must be coincide with the bottom. So for that reason we have to create the object. So I'm clicking on rectangle here. Not this one. Go for the normal rectangle. Pitch is fine. I'm creating one. So circle here. Go for trim option. Now exit movement. Now what happened here? Automatically it is showing some error here. Because I think you have selected the wrong page. Go for the wall on edge. Choose the option here of sketch page. Select the profile as and wall on profile I'm creating somewhere here on this page. And I'm creating a rectangle here. Now I am creating a circle here. To get that shape, I am creating this one. Exit workbench. Switch through okay. It's select that add profile, select this plane. Giving some dimension to this line. Giving the dimension to this line, to this line. Making trims here. Exit workbench. Still it's scrolling here. Then 90 degrees I want. And now it's creating. Now it's creating here. I want with the bend. So like that. So how your shape you are giving here, that shape only it will create but okay. So like that we can able to create the flanges or more on edge by using automatic or sketch base. In automatic you have to it will automatically take a rectangular shape and it will create the flat. But whereas when you go for the sketch base, here you have to specify or create the sketch. And remember one thing, the sketch bottom edge must intersect with the edge which you selected for the flat. Okay, remember this. Guys, we will do one thing. I am stopping here only. Tomorrow I will complete all the commands except these stamps.